Okay, so today we're going to learn how to balance equations, and the whole point of balancing equations is that atoms cannot be created or destroyed. You can only change the way that the atoms are bonded to each other. So here we've got an equation that we're going to have a go at balancing as an example, and then we're going to work through a few others just to make sure that that's understood. So I'm going to first of all draw out the atoms here to show what's going on. So here I've got H2. That means that there's two hydrogens going around as a pair, as one molecule. So we could represent that like this. That's my two hydrogen atoms going around as a group. And that's going to react with O2. So they're also going around as a pair of atoms. And then what I make is this water over here. So that's made up of one oxygen and two hydrogen atoms. Okay. So the first question is it already balanced? And the way to tell that is, are there the same number of atoms of each type on both sides of the equation? So I've got two hydrogens here and I've got two hydrogens there, but I've only got one oxygen here, and I started with two oxygens and I can't have destroyed one of those atoms. So where's it gone? But the answer is the equation isn't balanced, and it needs to be in order to show where it's gone. So if I want to have the other oxygen on this side, I can have another oxygen, but I need to have another two hydrogens with it as well. And the way that we show that is by putting a big 2 in front of the H2O to show that there's two of them. It's really important to understand that you couldn't have put the other oxygen in just by putting a little 2 here. Okay, if I had this H2O2, that would be balanced, but this isn't water. This is what's called hydrogen peroxide, and hydrogen peroxide is a powerful bleach, and it will be extremely bad for you if you drunk it. So it's not the same thing as water, and we can't change the little numbers. Okay, it's really important to understand that you can only put big numbers in front. So I've done that, and now I've got my two oxygens here and on the other side. But what I've done as well is I've now made it so that I need 4 hydrogens, and I've only got 2 there. But we can make up for that. So all it means is that we also need another hydrogen there, so that there's 2 molecules and each of them contains 2 hydrogens. And so I would write that like that, and now it's completely balanced. I've got 4 hydrogens here, 2 pairs, and I've got 2 oxygens there, and I'm turning it into 2 water molecules here, and it's got the same number of atoms of both types on both sides of the arrow. Okay, so we're going to look at a couple of other examples just to make sure that that makes sense completely. Okay, so we're going to balance these 3 equations here, and we're just going to go through element by element, and that's really the best way of tackling it. So first of all, I look at the aluminiums here. There's 1 aluminium on this side, but there's 2 aluminiums on that side. Okay, so what I could try and do is I could make that a 2, and then I would have balanced the aluminiums. And you might try that, and now we carry on. So there's 2 oxygens here, but there's actually 3 oxygens on this side. There's 2 ways of working this out and making it balanced. One way is to just keep adding to the side where there's fewer. So I could make that 2 O2s, so that now there's 4 oxygens, but I can't have 4 oxygens on this side. The next biggest number that I can have here is to make that a 2, and now each one contains 3, and there's 2 of them, so that's given me 6 oxygen atoms. So how can I have 6 oxygen atoms? Well, I can have 6 oxygen atoms if I made this a 3 here, okay, and that would work. And I also now need to go back to the aluminiums, because now there's 2 of these and there's 2 aluminiums in each, So there's actually 4 aluminium atoms. And so I need to make that one at the start of 4. Okay, that one was quite tricky. We'll have a go at the next one. So the NAs. There's 1 Na there, and there's 2 here. So I could increase that to 2. Let's have a look at the oxygens first. There's 2 oxygens there, but there's only 1 oxygen on the right-hand side. Okay, so what I can do is I can increase the number of oxygens here and make that 2 of those. And now I've got 2 sodiums in each of these, and I've got 2 of them. So that means that there's 4 sodiums altogether. So I need a 4 on that side. Okay, and finally, we've got the reaction between sodium and water to give sodium hydroxide and, that should be just H2, not H2O. Sodium hydroxide and hydrogen. So then we're going to try and balance this. This one's quite tricky. So you can see here that there's 2 hydrogens there, but 3 on this side. So I'm going to need more hydrogens here. So I can try and make that a 2. Now there's 4 hydrogens here and 2 oxygens. Well, there's 2 oxygens here, but only 1 oxygen on this side. So if I put a 2 in front of that, I now have 2 oxygens on this side as well. Let's look back at the hydrogens. So there's 2 hydrogens there, but there's 2 of them, so that's 4. And there's now also 4 hydrogens on this side because there's 2 in this and 2 there. So that's 4. But the last thing I need to check, every element must balance, is the number of sodiums. So there's 2 sodiums on this side, so I need 2 sodiums on that side as well. And that is how to balance chemical equations. Sometimes you'll find that you've worked through it and you've got some numbers that are bigger than they need to be. Okay, so I could have balanced this so that it said 4, 4, 4, 2. Okay, and that's still actually balanced, but all of these numbers are larger than they need to be. And the way that I spot this is because I see that all of these numbers here, they all have a common multiple of 2. So I can factor it all down to 2, 2, 2, 1. Okay, but actually this would get you the mark in the exam because it is still a balanced equation, because it still has the same number of elements at the start in the reactants and at the end in the product. So it is still balanced. So the examiner would accept this completely, even though it's not the simplest expression of a balanced equation. Okay, well I hope that's helped you understand how to balance equations. Definitely seek support from your chemistry teacher. If not, and have a go at practicing some more balanced equations. Really, you get faster and faster and faster the more of these that you do. Okay, thanks very much. Bye.